This is the point in C#1 where people sometimes are having a hard time ascending the learning curve. Is that a good way to put it? The learning curve, if you know, is kind of like a curve that you keep going up, up, up as you're learning, and finally you plateau in a subject, and then you start, going down, diminishing returns where you're not learning as much about it all the time. With C#, we have a really, really steep learning curve at some points, because there are some things that you just have to try and just do, and then they start making sense to you. So hang in there, keep, your footing strong, and all of your, what do they call those things that you guys attach yourselves to the mountains with? I don't know, make sure they're all attached really well. This is why I like people to work with groups, so that they can turn to their group when they have a problem and are feeling confused, and get some help. So if you're not confused, well, hang on, because this chapter should make it a little bit more exciting. So this is definitely one of those ones where you're going to have questions, and there's going to be things that aren't all connecting and making sense. So we're just going to keep forging ahead, and then all the pieces will fit together into place. But it's kind of like making a big Lego model. You might not know exactly what you're doing until you get to the end. So we have to just keep going along and trying to get there. We're looking at creating classes, creating our own data types. We've seen C# so far as very type specific, right? You always have to tell it, this is a string, this is an integer, this is a double. C# wants to know what type things are. Why is C# so popular in the world? Because you can create your own types, your own data types, and you do that by creating classes. So far we've just had that class statement being a border, an outline of our code. We've used the class statement that's called the class program. We've seen where Replit has kind of switched. They wanted it to be named main class, and then they want it to be named program. But we haven't really had to worry too much about using a class per se. The classes give us all of that ability to create, I say, our own data types. So there's a video that I want to just play just a little bit of. In your module section. And I'm just going to play this very first video a little bit, because I don't have Unity installed here. So this is a Unity application that's real simple. It gets going here. Okay. So this Unity application is just a sphere emitter, right? That's all it is. It's just emitting these spheres, these balls out into the space, into space and time. So let me pause it here while it's thinking. Each of these spheres is an object, right? They're a sphere object. So we could think of each of these spheres as their own class. So I'm going to write that down up here at the top, that a sphere would be our class name, and that's the object we're trying to define. So tell me about this object. What kind of characteristics does it have? What's a property or an attribute of this object that looks like it could be different for different instances of the object? Each of these spheres that we see on the screen is an instance of a sphere, right? So what are some attributes that could differ? Are they all the same? What kind of attributes do they have that differ, make them differ? Say louder.
Different colors.
Different colors. That's good. For sure. What else?
Different locales, different
Positions. What was it?
They're just being propelled in different directions.
Different directions. So
Vector.
trajectory, that's that word. We could say that they almost look like some of them might even have different physics applied to them, right? Kind of depending on where they are. But that's a really good start. Those are different attributes for each of the spheres that we have displaying from the sphere emitter. So what are some actions that some of these spheres could perform? Well, one of them, I'll tell you right off, is instantiation. It's a really big word. It should go in your notes, as all of these terms should. Instantiation is the creation of an instance. So every time one of these spheres is born, it is instantiated. So our big word, well, one of our big words for the day, we have several, but instantiation is that process of being created. So the birth of an object is an instantiation. So that kind of action always exists for any kind of object, right? We can always do that. What other things does our objects do that you notice? They're moving, right? So we could say that. Now, a couple of other things that our objects do that we might not even be aware of, but say we have some sort of target or something that these spheres are going to be trying to hit, right? Well, if we are looking at our target, we might need to know if one of the spheres is touching it. So we could have some sort of actions for collisions. We see collisions occur here and they kind of, shoot off of each other. It alters their trajectory, right? If they have a collision with another sphere. So that's a kind of action or behavior of our spheres. Another thing that we might do is our target might want to know if any spheres are approaching. Maybe our target wants to change colors or do something really cool as spheres get really close to it. So it wants to know what the position is of those spheres. So we could allow it to get the position of a sphere, right? That would be a good action that we could perform. We wouldn't let that target just go change the position of a sphere, right? That wouldn't make any sense. But we would let them get it to see where it is. Is it getting close to me? Is it getting close to me? I might have to check all of the spheres that are on the screen to see if they're getting close to me. Depends on my code. So any of these attributes, I might allow the ability for other objects to get those attributes. We call that a getter. So like I could get the color or whatever attributes I wanted to know about my object. Now, like I said, we wouldn't let just anybody update this information, but maybe we do want to allow that is an action that could happen at some point. So maybe we want to let people set the position and set the color. Getters allow other objects to get information about this object. You all have getters. If someone walks up to you and says, "What's your name?" you use your getter and you tell them, right? You let them know what your name is. You have a getter for that. Setters are a little bit different. A setter updates the information. So if I walk up to you and say, your name is Joe, he might say, no, you don't get to do that. You don't get to set my name. But I did let my parents do it once, I've run it once. But when I'm setting like my position, I might have some sort of controlling aspect that can move things around, that could set those positions, or a collision could cause a change to my trajectory. So it's common for us to have both getters and setters. So what we have in the end here is a basic class definition for a sphere object. Let's make a UML diagram that matches this so we can have some documentation. We have people at home that can't see this very good. Let's see if I can give it to them. Not very good. If I turn the camera on, they wouldn't be able to see anything. Okay, it's letting me connect just a sec here. Oh no. I'm not sure how to update that. I'll have to do it later. I'll get it for you. When you guys do it. Okay. So let me minimize this and let's go create a UML diagram to match this. Go with me to portal.office.com and let's log in using your OTC account. I'm already logged in. And a UML diagram is short for Unified Modeling Language. So whenever we are looking at creating a class, we could call that a model, right? Our class is going to be a model of what this sphere object is going to contain. Okay, did it let you log on? Here at Microsoft Office Home, over on the side, you have a toolbar. At the bottom of your toolbar is the 3-dot menu. That's the one we want. Click on it. Do you guys see Visio?
Yeah.
Yes, no, yes?
No, we don't see it.
Lots of people see it.
I don't see it.
Are you clicking on the 3 dots?
I don't have.
You don't have three dots.
Click on the all apps and then you can scroll down.
Where is all apps?
The square on top.
Ah, it used to say it down there. That'd be the best way. So click all your squares, do all apps, and we should be able to find it. Visio. Now Visio is a drawing tool. And you could use it, you can download it from the Microsoft tools place. There's videos and all that stuff in our Canvas modules and our setup module that talk about installing Visual Studio. If you want, you can download Visio and install it, but they have this online version. So that should be good enough for us for what we want to do. And what I want to do is I'd like to find a UML diagram template. So I'm going to click on more templates here and see what they let me have, because I haven't used this online version. So I'm like, cool, I'm glad it's here. Don't really want a flow chart or network diagram. None of them look great, very good. I'm going to search for UML. How about UML class? That looks good. Nope, I'll just search for UML. Nothing. So I'm going to do a new blank drawing. Now, when you're using Visio, you have shape libraries over here on the side, and then this is your drawing page, your piece of paper here that you have, and you can use all the different shapes in any way that you like. So like if you wanted to draw a rectangle, you can select that rectangle shape and then click and drag to draw it on your piece of paper. Is it working? Oh, I have to drag it from your shape library out onto your piece of paper. I'm going to search for UML shapes. Come on, you silly thing. Nothing. So we'll just use a rectangle. Notice over here, there's a little teeny toolbar. Could do basic shapes. I'm going to click add shapes just real quick to see if I can find the UML is really common. It should be out here. I don't know why it's not. So I'll just do basic shapes, and let's do a rectangle, and we'll draw it on here. And what I want up at the very top is I want it to say the name of my class. So I'm going to double click on that rectangle to open it up for text. And I'm going to type in the name of my class. We decided this class would be named Sphere. Then I want right under the title, I'm going to start listing all of the attributes or properties, the data items that belong to my class. So for this one, I would have color. I'm going to put minus sign in front of color, and I'll explain that in a minute, and my position, and my trajectory. Now those are all our attributes. I really would like them to be left aligned. So I'm going to choose that left alignment. Now, when we're doing a UML diagram, we have our class name at the top, then all of the attributes of the class or properties that belong to the class. I put the minus sign because these attributes are private to our Sphere class. We're not going to let our enemy class or our target class update these variables directly, right? They're going to be able to. They can use our setters, but they can't just willy-nilly update our variable values without us saying it's okay. So now, under our attributes, we want one more grouping. And this grouping is going to be all of our actions, our behaviors of our class. So the first thing I'm going to have, my instantiation. These are all going to start with pluses because they're going to be public. We're going to let other people or other classes interact with our sphere class using these behaviors. My instantiation behavior is always going to be named the same as my class. So I'm going to put that behavior right there, that I have a behavior to create a new sphere. As we've coded, we've noticed that when we call methods or actions, we have to put the open and close parenthesis after the name. And that's what this is showing, that open and close parenthesis. There's no parameters. We could maybe create spheres where we let somebody send us the color. We'll say that we would take a color. We could have multiple actions that involve instantiation, right? One that sets properties, one that doesn't. Now, the other actions that we said our object was going to have, we're going to have a move. We're going to have something for collisions. And I'm going to make my rectangle here a little bigger because we have a few actions. Whoop, not that way. Select it and drag its resizing handles just like it were within Word. And after collisions, I have my getters. Get position, get color. We might have a get trajectory. Then our setters, set position, set color. Now, all of these, I'm putting my open and close parentheses at the end, but I might, if I had parameters, I would indicate that on my UML diagram, kind of like I did here, where I said that I could be instantiated with a particular color. Now I'm going to go ahead and left align all of these. And that looks pretty good as a UML diagram. UML is kind of one of those standards that's really flexible, floaty. So you'll see different versions of UML diagrams. But the bottom line is we should have our class names first at the top, then all of our data that goes along with the class, all of our attributes or properties. Then lastly, we shall have all of our actions or behaviors of that class. Now, one thing to notice looking at this, when I was looking at the screen, I saw blue dots and green dots and red dots. Those are data values, right? So those are different values I might see for this color attribute. Those are not part of the class. So let me ask you a question. If I look out here at students, what are some good attributes for students that we would want to keep track of?
Attendance.
Do what? Attendance?
That sounds what you speak.
Is that what you're thinking? He's interpreting for me. Thank you. What else? Yell loud. Do I want their names? Do I care what students' names are? Yeah. Probably. Do I care like what class they're enrolled in or things like that? Think about the data. Now, when I'm creating a class that defines students, I am not going to have a data value, Joe, Sam. Those are just pieces of information that might be used. What I'm looking for here in my class is the template, the definition. What are the attributes? Name, not what are the values. I don't care that there's Joe and Tim and Bob. I care that there's name, right? That the name attribute is what has to be kept track of for students, not the individual students. And I say this because oftentimes we'll see people get confused by that. They start thinking, oh, I'm going to have Milwaukee, Chicago, Orlando is cities. And they start putting those values here in their data area. And no, those are all just different values for one property, the city property. So remember here, what we're looking for is the template, the skeleton, what has to be known for every single sphere we create. Let's put a couple of things on there and finish it up. Oh, Chloe asked, they all have the same size. Yeah, our spheres do all have the same size. That's a really good question. But that could be something that we allowed for deviation of, right? So that might be something that we wanted to add as a property and then associated getters and setters for. That's a really good thing that we might have to keep track of. For our basic shapes, though, let's go ahead and put a title on this thing. There should be, I guess I can just insert a text box up here, and I'll say something like sphere UML diagram. And then I should be able to just have that saved. Right now it's named drawing. That's not a very good name. I think I'll change it. And let's change it to sphere UML diagram. And I'll save that instead. That'll be a little bit more meaningful for me. Okay, so that's classes. As we create a class, we are just creating the template, the framework for what we want to keep track of. In our textbook, they have quite an overwhelming project that they create in the chapter. So let's see if we can do that. It's a very big project, and it jumps around a little bit. So like I said, it's definitely one of those that's going to require some sticking with it. Let me find it here. So what I'm looking at is chapter 5. And I'm going to start right at the beginning of the chapter. And at the beginning of the chapter, they have some object-oriented terms that are really important, but they can be kind of, I don't know, difficult to understand. So let's think about encapsulation first. I'm going to bring a tab over here, and I'm going to search for encapsulation. And then I'm going to look at images, because I want a picture of what encapsulation is. I see all sorts of pictures. And right off the bat, I'm seeing all sorts of capsules, like medicine capsules. And then I'm seeing a little bit of talking about programming encapsulation. But what does encapsulation mean overall? Well, it means enclosing something within something else. So what we're doing here is we're encapsulating all of these attributes and all of these actions or behaviors that a sphere can have. We're going to encapsulate all of that into our sphere class. So now our sphere class contains all of those things. So that's the encapsulation aspect. Everything is contained within our class. Composition is one that won't do us as much good to do a search and look at images because it's not something that is really image oriented, but it's what something is made of. So they say a car is composed of different parts such as 4 wheels, seats, and an engine. Well, we saw our attributes for our sphere. The composition of a sphere was like the color, the position, the trajectory. All of those things are how that sphere is composed. Now, aggregation is when we work with multiple objects together. So we talked about that if our sphere was interacting with some sort of target, we would have to be concerned about the aggregation of those two components. Is a sphere touching the target? Is a sphere getting close to the target? That aggregation relationship would be important to us in our code. Now, inheritance is where I can take things a little further. Maybe we've got this great sphere class already implemented. It's working as a data type all over. And Chloe comes up and she's like, I think we should be able to change the size of spheres. So we are like, oh, that's a great idea. Let's create a new class that inherits from our sphere class, but it allows for spheres to grow and shrink. And so we could make that a child of our sphere class. It would still be dependent upon this base sphere class, but it would be able to use that data, inherit from it, and add more to it. So we can see that that's kind of a concept that gives us even more power in our programming. Abstraction. This is a hard one. I can search for it. Let's search an image for abstraction. Sometimes we forget what words really mean. Still not too great, but I do see some. So this is abstract. Here's some abstract art. Right? Abstract art doesn't necessarily show anything, right? It's all subject to interpretation. Well, that's what we want with our class. We want it to be so abstract that people can use it without having to know the details of how things are put together. So for our sphere class, we don't have a lot of complication here, but think about it. Maybe in our get trajectory method, we do some really hairy calculations. We don't want the programmers that use our get trajectory to have to worry about those calculations. We want them to just be able to use that trajectory information. So that abstract capability keeps that complication away from the other programmers. They don't have to worry about those calculations. They know we've already got it under control and they can use it. Lastly, polymorphism. That's an interesting one. Let's search for morph, because that's really what we're talking about. All I've got is the morph guy, so he's morphy. Man, oh man, he's just taking over the edge thing here. I don't know so much about edge, but I'm looking for pictures. But that is a good picture for polymorphism. What we're saying is, I want to be able to change this guy into this guy without too much work. I want to be able to morph this base guy into something a little bit more specific. And I should be able to do that by using the same kind of muscle building methods that I would use for this guy. So polymorphism is the ability to kind of override one thing with another thing without too much work. So we'll get into that. All right, let's see if we can do this. We're going to start here with Visual Studio Code, and we want to build a reusable .NET class library. So a class library is going to be a series of .cs files that declare different objects, different classes. And then we'll be able to reuse those objects, those classes in other code. So let's see if we can do this. Let me see what our message is here. Can't find it. Come on, teams. Okay, so I want Visual Studio Code. And I'm going to try to follow these instructions. And I'm starting on page 142. So the first thing I want to do is create this class library. Let me get myself situated here. So I want to go to create a folder named Chapter 5 with a subfolder named Packet Library. So let's do that. File, open folder, and then I'm going to go to my folder. Let's see. Last time I ended up having to put stuff on the C drive to get it to run right. I'm going to try to use my external if I can. So I've got a couple of chapters in my code folder that I've been trying to use on my external. I'm going to create a new folder here for chapter 5. And then inside my chapter 5 folder, I want to create a new folder called, what do they want? Packet Library. So be careful with this name. They've got P-A-C-K-T and then library. So we've left the E out of packet. And that's the way this publisher spells their name. Now I want to select that folder. And I'm going to say, yeah, I trust the authors. You probably aren't getting this message. You may be, depending on where you have your code. And we're going to look at a place for saving our code for source code control in the next lesson or two. So for right now, be sure that you're keeping your code in a place where you can find it, blah, all that kind of great stuff. All right. I've got my chapter 5 folder created and my packet library folder. I want to add this folder to a workspace. File, add folder to workspace. And I want my workspace to be in my chapter 5 folder. Whoops. I want my packet library to be in this workspace, so I'm going to choose it and choose add. Everybody good? Now we've got our folder hopefully created and added to our workspace. And I need to go to a terminal and I want to enter this file, the command .NET new class lib. So far we've been adding a new console project. This time we're going to add a new class library type project. So I'm going to open my terminal window and enter that command, .NET new class lib. And what I hope to see is that my class library was created successfully, and I've got my new files over here under my Pocket Library folder, class1.cs. Now, because I created a class library, code named that CS file class1 instead of program. So notice right away, we've got that little bit of difference. I'm going to get my textbook out of the way here so I can see it. All right, now that we've got our class library project created, let's open the CSproj file. There it is, our Pocket Library.C# project. When we look at our project library or file, we want to make sure our framework is .NET 5.0. At least that's what they're using in our textbook.
Do you want us to manually change that to 5?
Do I?
Do you want us to just manually change that to 5?
Yeah, you should be fine doing that. Actually, they want us to change it a little bit more. So instead of using .NET 5, they want us to put Net Standard 2.0. That should be all that we need to change. So they say to save and close the file. So I'm going to save this. And then I'm going to close this tab so that I don't still have it open. Did you notice how it had that little black dot there that it needed to be saved before? All right, so we've updated that to be .NET Standard 2.0. Now we're going to do our class itself.
Uh-oh,
What's the matter?
there's a problem.
Do what?
I'm having a lot of problems, actually. 49 of them.
So where did you enter that .NET new command down on your terminal? So that looks good. So try .NET space restore. Right there where you are on your terminal. Yeah. .NET space restore. And that's a command I've had to enter a lot since we've seen some of these changes.
Uh-oh.
.NET being the word dot.
Oh, sorry.
Why do you have a bin in an object folder already?
Because we saved that file and we changed it and it did not like it. When we changed it to Net Standard 2.0.
It didn't like it at all.
Yeah, I just changed it back to 6.0 and it got rid of all my errors.
Did it? We'll try it. Just remember that. So yeah, it was a Net 5.0 without any spaces or anything. And save that. Did you save it? Okay, so in our class file, we are going to make this be a person class. So we want to rename this class file So let's rename it. And I want this to be person, oh, come on, person.cs. So now as soon as I name it person.cs, I'm going to get some errors, so just relax and wait until you fix them. Just relax and wait until you fix them, okay? We're going to have some errors. Now, in this class file, once we rename it, we need to do some other things with it. So let's change the namespace up here.
Can you share your screen again?
Oh, sure. I think Anna killed it. You gotta let me know when you're sharing. Can't just take over like that. Okay. Our namespace should be packet.shared. And we want our class name to match our file name. So it's going to be person. So uppercase P, just like our CS file name. Now, notice that our class is public. And when we're working with a class library like this, we always wanted to use the public keyword because it wouldn't do any good for this class to be private, right? We wouldn't be able to use it anyplace else. So public would be what we want all of our classes to be. Now, as we start working on our class, we're going to be resolving our errors and stuff as we go. So we're going to be looking at creating members to our class. Members are all of the things that are encapsulated within our class. So we have our data fields, and we can have lots of different types of data fields. We could have constant data, you know, like the value of pi, just like we saw when we're creating a variable. We could have read-only data that we don't update after the class has been instantiated. We could have event type data, like things that say something should happen, like clicking a button. And then lastly, we have our regular actions, our regular methods. So all of these types of things are going to be created within our class. Now, as we create this class, we're going to need to have a reference to it. So we want to create another application that's going to be our tester for this class. So right now, our person class is looking kind of sad. We have some errors and things that we're going to be resolving. We're going to leave that for a second and create another folder, another project. So let's see if we can do this. We want to add a folder to our workspace, but first we've got to create it. So I'm going to choose Open Folder. And the folder that I want to open is going to be called People App. So let's create a new folder. People App. I'm going to cancel. I don't want to open that folder. I got it created. So now I want to add it to my workspace. So I'll go to my Add Folder to Workspace, choose my People App folder, and add it. Yes, I trust the authors. Okay, is everybody okay then? Your workspace should have Untitled. You might have yours named properly. Mine is still named Untitled, but underneath it I have my Packet Library folder. and my new people app folder. So I want to update my people app. So let's go to your terminal. Do I? I just canceled out after adding it. You got it?
No.
What's the matter?
How do I add the folder to it?
Okay, go ahead and take over again.
Like, do I put it there?
Are you going to share your screen?
Yeah, I'm just gonna show it clear if that's okay.
That'd be great. Thank you. You okay?
Yeah.
All right. So let's create our new project then. .NET, new console, and this needs to be using, I'm going to say -- framework 5.0, so that it uses that older template. And that should create a new console app. Oops, I'm not in the right folder. Let me click on my people app folder. I'm closing my terminal and going to open a new one. I know there's an easier way to do that. Select current working directory for new terminal. Well, I want to select my people app, so I'll choose it. Notice how right now it's looking at my Pocket library. Go to my people app folder. Did everybody get there okay? And now I can enter my .NET new console framework .NET 5.0. So I had to make sure I was in that correct folder before I could enter the new command. Okay, so we should have an Angry project in our Pocket library folder, and our new people app folder should have a program.cs file like we've seen before. But let's update our people app project folder. So people app.csproj. We want to add a statement, or actually a group of statements. So after our property group, we're going to add an item group. And when you press enter, notice it automatically closes the end tag for you. And it's got some nice IntelliSense here. I want project reference, and where that include equal, if you notice I just arrowed down to that and press tab or enter to drop that into my code. Now I can put my path name here. I start with 2 dots, which means based on the current folder, go up a folder. That will put us at our Chapter 5 folder. And within our Chapter 5 folder, find Pocket Library is a folder name. And within that folder, find Pocket Library .csproj. So notice how this reference is just referring to our project file in our class library that we created already. So that's tying those two projects together, that reference. Let's save that. And let's take our break, late break. Come back at 9:30, please. Late break till 9:30.
Sorry, I'm in plenty of years. She didn't hear.
Are you guys all just staying? Should we just keep working? Got some? Nobody's taking a break?
How do I get?
What's the matter?
I can only see one terminal. I did get two.
I did the split terminal. So it was on my terminal option, split terminal. When you split that terminal, then you can have two different folders showing. So this first one, I left it in the people app folder. The second one, I did this CD command, CD space dot dot backslash packet library, to put it in our packet library folder. Is it letting you? Not showing.
I'm not exactly what sugar keep us talking about. Oh, I think.
This was new people. Okay, so we're in our actual executing program. Let's put some comments in here. I'm still got to get my using statements all the rest of the way in. So I've got one using statement to say I'm going to use that packet shared namespace. And I'm going to put in my using static system.console, so I don't have to keep typing that console keyword. And then I'm going to put some comments under my namespace. So we'll call this our person class tester, because this is going to test our person class. Put yourself as the developer. Act as a tester for the person class. Now I can leave this class named program. I could change it if I wanted to. Some people like it to be named like tester or driver or something like that to kind of remind them what it's doing. But I don't want to input any errors at this point. So let's try to just create the code that they gave us. Do you guys notice that I have color-coded curly braces? Do you care? I do. So what I found was it was an update. We'll find it in a minute because I don't want to get off of where we are. I'll show you how to make your curly braces colored. But before I do that, I want to get this main ready. So first, we're going to set up a variable, hold an instance of our person class. That variable's data type they're going to name it a var type variable, which is fine. That just means that it's flexible, and C# is going to figure out what the data type is when we compile. So we're going to name this instance Bob, and he's going to be a new instance of our person class. So this is the code we use to create a new instance. Notice it always has that new keyword. So we're saying, I want to create this variable named Bob, but it's going to be a new instance of the person class. Now after that, we're going to write some information out about Bob. Let's write line, and then no double quotes, Bob dot toString. We've used toString before, haven't you? You've used it like to format a number as currency. You put the .toString. Well, toString is a default system method, which means convert something to a string format. So we'll use that toString method in our classes to output things as strings. Okay, let's see if we're going to be able to run this thing. We should be able to. Now our person class, if you remember, is pretty empty. If I look at it, it doesn't have much in it. It's got nothing in it, right? Our Bob guy is really not got a lot of data characteristics about him, so we'll be building on that. I want to run this now. And I'm going to try to start debugging. And I want to run. Oh, and I've got my problem here. Let me delete this launch.json. And what I'm going to do is in my terminal window, I'm going to go to my people app terminal window and enter the command .NET run. So something happened. Did you guys get the same output? Packet.shared.person. Did everybody get that? Yeah, got it. But that's what we expect to get because our person object doesn't have any sort of data or any information. So when we said, turn that person object to a string, the system said, oh, this is all I know about it. It's in this packet.shared namespace, and it's named person. So that would be the correct output that we should get. What have you got, Anna? Something different?
For some reason, my person file, my namespace says it's in C# 7.3. So my namespace isn't file scope. File scope namespace is not available in C# 7.3.
Can you show me? Take over and show us what you're talking about here.
That's what mine's doing.
Let's look at your person.cs file. And I think that it did something weird to our namespace. Right after where it's got your namespace and it's got the semicolon, get rid of that and make it be an open curly brace. And then put the closing curly brace down at the very bottom after our class. Save that. Now, what happens if you try to run? So let's save everything. Do file. And let's see what it's mad about. Where it's got the red by packetlibrary.csproj, let's look at that up there in your folder list. So that looks right. It says .NET Standard 2.0, right? That looks good. So let's expand it. You click on it. Not showing us anything else. So let's go to your program.cs. And I think I see the problem in your program.cs. ToString has have an uppercase T. So the other things were problems too. Now let's see if that takes care of all of them. Okay, is everybody's okay? Lots of little pieces here that we're trying to connect together. So good job. You're super picky. Let's see what you've got. So what does it say down there? What it says, the C character cannot be included in the name. What's it talking about? Let's look at the error message, Anna, down there in the red. What line of code is it telling you have an error on? Yeah, look at the red message. Look at the red message down there. It says, look at the red message where it says error. Right before that, it tells us what line number the error is on. Right down here. Huh?
I think it's in your people app. In the program.
So what file is it saying? It's saying people app.cs project, line 8. Doesn't know what that letter C is there after the word item. Should it be item group? So it would match the bottom. So change line 8 to say item group instead of this item G. And then get rid of that beginning stuff in the project one too. And then save that. Anybody else? Let's see if what that should fix.
No.
And did you save it?
It still doesn't run. What's going on?
I guess I'm having a problem with the packet.shared at the top of my program.
Uh-huh.
Yeah, that's what I'm also.
Are you?
I
Okay.
don't know.
Get rid of that nullable, Anna. We had to get rid of all of the extra things in that file except the target framework. Now let's save it. Great. Okay, so let's see that one. What other problem are we having?
So I guess
Good job.
I'm having a problem here. It's saying 2.7, so it's saying it's having a problem with this right here.
Can you zoom in a little bit? Will it
Maybe,
let you control scroll? I don't know.
yeah, I guess it's not zooming in very well.
Wasn't there like some uppercase in there?
Is it supposed to be uppercase packet?
Well, it has to match exactly.
Oh, it did change color, so maybe that'll do it.
Yeah, that looks better.
It's still giving me that same 2.7 error.
Okay. The type or namespace name PACKT could not be found. So let's look at your person.cs class. Go up in your previous project.
Oh, the person does it.
Yeah. And classes should always be named with an uppercase letter. So that's why the P should be uppercase there. And it should also be uppercase in your file name, person.cs. So we always name classes with an uppercase letter. Then, we happy? Is it happy now? Now, so let's look at your namespace has a lowercase s there, and you made it uppercase in the other one. So you guys have to be consistent. All these little pieces have to match up together.
Yeah, I guess it's just capitalization.
Yeah, capitalization's a big deal.
Oh, it's not that.
Still causing us trouble. So have you saved?
Yeah.
It says the type or namespace PACKT could not be found. So it's a typo either in that namespace somewhere. Do we need a space after that namespace before the opening curly brace? Doesn't care about that. So let's look at your people app project file. And right there, pocket library.cs project looks right to me. And in your program.cs,
It's because he's missing the / packet library.
Yep,
you see it?
he's only got one.
Two.
Ah, thank you guys. So before in between the two slashes, you need that packet library, your folder name.
Okay, so I have the.
Yeah, you have it within this folder though.
Oh, okay.
Thank you guys. I did not see it.
Hey, can you check, line 10, check if reference is spelled right?
Is there a typo there?
I don't know why it's not giving me like error lines though. I feel like at Visual Studio, but Visual Studio Code doesn't. I don't know.
Yeah, it's very picky as far as getting all these commands set up properly. Much harder than Visual Studio. Much harder. You guys are just whipping it into shape. So, okay, he's running now. All right, I'm going to take back over. Yeah, it's definitely harder to get all of these pieces working together with Visual Studio Code. You guys are definitely seeing under the hood a little bit more.
Is there any problem if we like use Visual Studio and then import that to other things?
Yes, you won't know how to do it in Visual Studio Code, so that would be a problem.
But why would we need to know how to do it in Visual Studio Code?
Because that's the preferred editor right now in the programming world. If you were to search, and you might very well get to work at a shop that has not spent the money for Visual Studio. Visual Studio is very expensive. And if you're using Visual Studio, you still need to have the same level of care and concern to make sure that you're making all the pieces fit together properly. We would still have just as many problems with uppercase and lowercase issues. We just would have to look in a little bit of different places. So really not too much different, just a little bit different than what I'm used to because I'm used to Visual Studio. All right, now looking at the next section, we're going to actually get some things going here. Right now, we've been getting all the linkage built for our project, getting everything to fit together so that we know how all the pieces work. So we want to look now at both our person.cs and our program.cs files. So we should be able to close out of our project files. We shouldn't need to update those anymore now that we have all of our linkage in place between these two projects. So they say, click, hold, and drag the edit window tab for one of your open files to arrange them so that you can see both the person.cs and program.cs at the same time. Huh. Can you do that? Do you see how I did just drag that tab over to where it did a side-by-side display? So now I can see my person.cs and my program.cs together. You can also do the split editor right button or press Control backslash, it looks like, to see the two files side by side vertically. Our person object is going to actually inherit from the system object type. So they say on our person class here, we could actually have a colon, which stands for inherits from, and we could say that our class inherits from the system object, an object being any class that somebody creates. We could have that inheritance, but we don't have to. We could also use the alias for the system object called lowercase object. Either of those things refer to the default C# system object. And we're going to be inheriting from that default object. Just like when you inherit from your parents, you might get some eye color, hair color, things like that that you got from them, but you're also going to have your own unique characteristics. So we're going to use the system default C# object to inherit basic things like that toString method and some other things. But we don't have to worry too much about what goes on with that object we're inheriting from, because it's abstract to us. We could just use it. So that's fine. We don't have to have this inheritance clause at all. We can leave it off because it's the default that we're going to be inheriting from the system object. Okay, they say they want us to explicitly inherit from object. So I lied, I'll put that back. Now, click inside the object keyword, this keyword here, anywhere, and press F12. what you should see is the definition of the system object. So it's kind of like looking at a UML diagram. It tells us this class name is object. We can instantiate it using object. And here are its data elements and its actions. There's that toString action for whatever that means. This is our metadata, or what's behind the scenes for this system object. Now that opened in a new tab, so I can just close that tab after I'm done looking at it. These kinds of metadata information pieces will be more valuable to us as we go. All right, for our person object, let's actually declare some data fields. Data. We could also call these properties or attributes. All of those terms are kind of considered interchangeable. But as we create these things, because they're at the top of our class, they're global to the class. Remember that whenever we define variables, where we define them determines their scope. And when we define them at the top of our class, right under our class statement, they're global to the class. First, we want a string called name. And notice we're making these public right now. And we want a date time object we're going to call date of birth. So those are our two data elements that we're going to have for our person class. My date time is giving me a bit of an issue here, saying it doesn't know what a date time is. Notice if I mouse over the light bulb, I get a little bit of help that tells me to show the actions. If I mouse over the term that has the red squiggly line, I get a little bit more information. The namespace could not be found. Are you missing a using directive or an assembly reference? It doesn't seem like it. So I'm going to go open a search tab and say C# date time reference. It says that it's in the system namespace. So do I need that up here at the top? Using system. Notice that our person CS file, when it was created for us, they didn't put those using statements in. We're used to that with our program.cs file. They pop that in there for us. But notice with our class library, they didn't. So I was getting some unexpected errors there. So we have to put that using statement in ourselves. So now we have our two data elements for our person object. They have some information in our textbook that talks about these public access modifiers. These public modifiers are going to make these data elements available to anybody. So they're going to be updatable by code outside of our person class. That's something that could be a problem to us. So we'll be thinking about that as we go. Now, we'd like to be able to use these data elements to keep track of information for our Bob person. So let's update our main method over here in our program.cs file. After we create Bob using our new person syntax, we can actually access the data elements contained within our person class named Bob. So first of all, for Bob's name, I'm going to set that equal to Bob Smith. So notice this has to come after I create my new person, and then I can set his date of birth. I'll set it equal to a new date time for, oh, let's see, they're saying 1965, 12/22. It's when Bob was born. Now I want to change my write line here. Instead of using bob.toString, remember that was just giving us that generic name of our class, not very helpful right now. So let's change that a little bit. I want to do a write line like they have in our textbook. So I'm going to try to do it their way. Format, colon, and we're going to use parameter replacement here using a 0 parameter. Bob was born on, and then our 1 parameter, we're going to do some special formatting. D, 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 D. And then, so we're saying I want a date format. And after the comma, I'm going to specify that I want day, month, 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 then year, 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 year. Fancy formatting. My closing curly brace should come before my double quote. And then I want a comma after my double quote. And I'm going to pass in my arguments. arg0. Notice we're using some named arguments here. A little bit different, just a little bit different syntax. And then arg1 is going to be bob.date of birth. Try to get that thing out of the way. So the way they have this write line statement set up with the format colon, arg0 colon, arg1 colon, that's named parameters. So that's exactly the same as if we left those keywords out. We're just being really specific here and including them so that we know exactly what we're working with. Argument 0, Bob's name is going to replace parameter 0. arg1 is going to replace parameter 1. We should be able to run this now. I'm going to go to my People app. I have my terminals switched from my files, but I want to save everything first. So I'm going to do File, Save All. Make sure I get all my changes, and then .NET Run. Oh, and this time we actually got some data for our Bob person. He was born on Wednesday, 22/00/1965. Let's see, that seems a little bit wacky. My M's should be uppercase. See if that makes that date come out better. I'm going to save again. And remember the up arrow on your terminal brings up the last command you entered. So you can just do your up arrow to get your run command back. And now, oh, that's better. Now I see he was born on Wednesday, the 22nd of December in 1965. Okay, how are you doing? You got output? Anything? What can we look at? Let's get people fixed before we go. Troubles? Go ahead and share your screen so we can fix them. Let's see. Oh, in your first open and close curly brace, we need a 0 on your format statement on line 22 of your program.cs. Inside those, yeah, that should take care of it. Let's make sure. Did it run? Everybody else okay? All right. Let's find the curly brace thing. On your file menu, go to Preferences and Settings. I'll have to search for it. I'm just lying to you. Where was it? I'm going to go to Extensions and search for C# color code. And I found this bracket pair colorizer, and it says that it's in our settings.json file. I'll have to find it again. In your settings, if you can search, we're looking for bracket pair colorizer. And if you find that setting, here it is, I searched for bracket, and in the editor it says, here's the colorized bracket pairs, edit in settings.json, and then we can change our colorization. So it's these two, number 5 and number 6, editor.bracket pair colorization.enabled, it's true, and editor.guides.bracket pairs is active. And if you can't find that right now, don't worry. We'll find it again next time at the beginning when we have more time to make sure that it's all set right. Major accomplishment today, creating your first class library and a program to test your class. We can try next time opening it in Visual Studio if you like, so we can make sure that it's runnable. What I want to do though before we go is go back to my File Explorer, and I want to save my workspace because right now my workspace is still untitled. So I'm going to save workspace as Chapter 5. So that it has a better name. Oh, that looks good. Now I should be able to open that workspace next time when we come back and continue on with all of our pieces together. So good job. Get out of here. Stay warm. And I will see you next week. be working on the replit that is the classes. You should be able to be making a lot of progress on that.
It's gonna be cold out there.
Cold, cold.